Good morning, everyone, and thank you for joining me for this lesson on defining trigonometric functions. There are several ways to define trigonometric functions, but today we're going to talk about the connection of trigonometric functions, specifically sine, cosine, and tangent to the parts of right triangles and how to describe them with right triangles. So I'm going to share my screen at this time. And as I said, we're going to focus on the connection to right triangles. So if you remember, a right triangle is a triangle that has a 90-degree angle in it, and we're going to go over that later. But first, I want to go over the lesson objectives. There's two things that you should be able to do when this lesson is over. By the end of this lesson, you should be able to define the sine, the cosine, and the tangent in terms of the sides of a right triangle, so in terms of ratios. And you should be able to find the values of the three trig functions when the lengths of the three sides of a triangle are given to you. Now, before we get into it is too far, um, let's think about what this really means in the real world. There's a lot of applications of right triangles, and one of them you see here. This is a wheelchair ramp outside a building, an access ramp. And as you can see in the picture, it's a triangle. It forms a triangle with the ground, and part of the application of trig functions, and specifically the tangent, is to find the slope of this incline, because as you might imagine, things like weather and physical strength and what kind of device you're taking up or putting down the ramp can make a big difference in how hard it is to actually get up or get down. So trig functions have a lot of applications in that way. And when we describe right triangles, we have a lot of different terms, but today I'm going to focus on the terms that are germane to finding the ratios for right triangles, and that is the opposite side, the adjacent side, and the hypotenuse. Now, I've featured two triangles here, but you could have your triangle in any other orientation. If we look at in the left hand picture, we look at the angle on the right hand side, the smallest angle in the triangle. The side opposite the angle is the side across from the angle. So if you have a difficult time identifying opposite, draw a line from your angle to the opposite side, to the side that's across from you, and that's opposite. When somebody sits opposite you, they're sitting across from you. So that's the opposite side. The side that shares um, um, array of the angle with yours is the adjacent side. Now, you might be confused that it might be this thing called the hypotenuse, but the hypotenuse is always opposite the right angle. And I said we would come back to that in a minute. A right angle is a 90-degree angle. So the 90-degree angle, the side opposite that is always the hypotenuse. Now, if your triangle is facing the other way, as in the second picture here, then the opposite side obviously is the other side. It's on the other side. The adjacent side is still on the bottom, and the hypotenuse is still the longest side of the triangle. Now let's see if we can put these concepts together and use them in an example. So let me show you this. Now we have a little trick for this to remember the trig ratios, and it's called SOHCAHTOA. Some people call it soak your toe, but I prefer to call it SOHCAHTOA. That's the way I learned it. And basically, the first letter here of each of these words, if you will, is your function. So S is the sine, and O is opposite, and H is hypotenuse. So sine is the ratio of the opposite over the hypotenuse. Similarly, cosine, C, is equal to the adjacent side over the hypotenuse. And the tangent is equal to the opposite over the adjacent. So sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And I have a picture of that for you here. If A is the angle that I'm talking about, and the square corner here is my right angle, then the side opposite my right angle is my hypotenuse, and I have my opposite and my adjacent sides. Now that's my little trick. Now let's see if we can use that in an example. So let me show you this first example. So in this triangle here, I've given you an angle at the left-hand corner at the bottom, the acute angle. The right angle is marked accordingly with a square corner. The side opposite is 13 units, and I have it labeled as the hypotenuse. You might wish to do that as well when you're doing these problems. Find the hypotenuse first, and then label the other two sides. Remember, the opposite side is the one that's across from you, and the adjacent side is the one that is next to you. So sine opposite over hypotenuse means 5 over 13. Cosine adjacent, the 12 over the hypotenuse, 13. And the tangent opposite over adjacent, 5/12. Okay, then now that's my example. So now we're going to do another one together here. So let me go to the next slide. Here we have another example. This one, the side opposite is 8. The side adjacent is 15. And the hypotenuse is 17. Again, the angle is the triangle is oriented so that the acute angle is on your lower left. So once again, sine is opposite over hypotenuse. So you have 8 over 17. Cosine is adjacent over hypotenuse, which is 15 over 17. And tangent is opposite over adjacent, 8 over 15. And that's really all there is to finding the values of the 3 trig functions when the sides of a triangle are given to you. There's other instances where we do much more, where we're not given as much, or where we have unknowns, but the basic concept is the same. And I hope that you've gotten something from this lesson, and by now you should be able to define the 3 trig functions that we talked about. Let me go back to the slide here. You should be able to find the sine of an angle, the cosine of an angle, and the tangent of an angle given 3 sides of a right triangle. Thank you very much, and have a good day.